Hello and welcome back to the next installment in the video series running SQL Server on Amazon RDS. Today we're going to be taking a look at securing your RDS instance. So let's dive right in. So with AWS, like most public clouds, there is something called a shared responsibility model. So I mentioned this previously. It means that AWS is responsible for the security of the cloud, and you're responsible for the security in the cloud. What does that mean? Well, it means physical infrastructure, power, cabling, servers, switches, routers, all these sort of things are the responsibility of AWS. However, when it comes to configuring access to the application, who can physically get into it and what they can do when they're there, then that's your responsibility. So one of the first things is VPC is best. So if you deploy your Amazon RDS instance into a VPC, it's best to avoid public access to that instance. So access can only be granted from within the same VPC or possibly from a peered VPC. The best way to do that is to use a jump box with access to the instance where possible, and have your application set up in the same VPC or a peered VPC so that they can access the instance. I've shown you security groups before and how these work. I'll just go in and show how this instance is set up again so that you can understand that. Basically, the rule is tighten it down as much as possible. Always review those rules and make sure the access is limited to the ports, IP addresses and CIDR ranges that you need to have access, and don't allow anything else. For the SQL Server itself, authentication is available via AD as well as SQL logins. If you remember, when we created the instance, we also were required to create an admin user, and that is the closest thing that you'll get to a sysadmin. That's not an appropriate level of access to give everyone who is going to be using your SQL Server. So you need to set up your own roles and logins and grant the appropriate levels of access to those who need the access to do their job. So developers might have a lot of permission on one specific database, like they can create and drop objects, but they don't have access to other databases within the instance. Or it could be a production instance and you're allowing the developers read access so they can review production data, but you don't want them to be able to make any changes. DBAs, on the other hand, need to be able to do a little bit more. So we'll have a look at that when we go into Management Studio. First of all though, we are here in the AWS console, and if we click on RDS, as we always do, and we will bring up our DemoDB instance once that loads. So taking a look at the connectivity and security, as we said before, we set this up using the default VPC and the default security group. You don't have to stick with the defaults, but for the purposes of keeping things straightforward, that's what we've done here. If we look at the inbound rules, which shows who can get access to this security group, then what it's showing is that for the MS SQL type, which is port 1433 TCP connections, I'm allowing access to this IP address here. Okay, that is my home IP address. And if we want to always just check that, you can just click my IP and it will automatically fill that in for you. Also, we're allowing all kinds of access from within the security group itself, but there's not going to be any other access granted. So even if you know the full endpoint of this instance, if you're outside the VPC and you're not on this IP address, then you wouldn't have any chance of connecting. So let's cancel that for now and let's go into Management Studio. Okay, so here we are in Management Studio, and you can see the list of databases on the left hand side. We've got Demo 1, Demo 2, Nebula and RDS Admin. So RDS Admin comes with the instance. The other ones have been created by me. If we want to look and see which logins exist, there's a few built-in logins there that come with the instance. And there's John RDS, which is the one I set up to be the admin login when the instance was created, but that's all there is. As I said, using that main admin login is not really suitable for having multiple users of your application. Even if you were the only user yourself, you probably still want to create a different login so that you can't make mistakes. So what I want to do here is create a couple of different logins, John Dev and John DBA, and these are going to be used by different types of roles. So we just created them with a simple password. So in the Nebula database, we want to create the John Dev user from that login John Dev. Also want to create a role for SQL developers. I want to make John Dev a member of that role, and I want to make the role a member of the DB data reader role. So what that means is that within the Nebula database, any tables that are created, we'll be able to read the data from them if we're logged in as the John Dev user. Further down, we're going to create a John DBA user. But that is going to be, and also a SQL DBA's role. But that role is going to be a member of the DB owner role, meaning that it has full permission on the Nebula database. In addition to that, we want to make John DBA a member of the SQL DBA's role. So by using the roles like that, all you need to do is add extra members to the roles, and you can use the roles themselves to manage the permissions. It's kind of the same if you're using Windows authentication and you have groups. What you can do is create logins from the groups, and within the groups itself you can manage membership of who's in and who's out of the AD group, and it saves you creating a different set of permissions for every specific user. Quick scroll down as well. On the Demo 1 and Demo 2 databases, I'm going to give the same DBA role and membership to John DBA, but not going to give anything to the developer role. So let's run these in just now. And that looks like that's created fine. Quick refresh of the logins, and we can see that the John DBA and the John Dev roles now exist. What I'd like to do is change to the John Dev login and see what we can do with it. So quick check here, go to connections and change. I'm going to log in as John Dev. And as you can see in the bottom right, the login is John Dev. So I'm going to use the Nebula database and select star from customers, which is the only table that exists. As you can see, there's some basic information in a table there. So we've allowed the developers to have read access to the data in the Nebula database, but that's all we've done. So if we wanted to, or say John Dev accidentally types in drop database, or even maliciously types in drop database, because they don't have the appropriate permissions to do it, then it shouldn't work. So let's have a quick look. Okay, and as expected, cannot drop the database demo 1 because it doesn't exist or you do not have permissions. So in this case, I know that it just doesn't have the permissions. Let's change the login to John DBA, which is a far more privileged level of login. And back into the Nebula database, because we're DB owner, that includes a number of permissions. We can really do whatever we want in this database, all the way up to dropping it. I'm not going to drop Nebula because I'm going to use it in further demos, but let's drop demo 1 because, to be honest, it's just an empty database. It doesn't have anything going for it, it's just sitting there doing absolutely nothing. Now what we want to do is, because we are the DBA and we've realised someone's created a database demo 1 by accident, which we don't need, let's go and get rid of it. If we execute that, then it's allowed us to drop the database. So the main thing to remember when it comes to organising access within the database, just like running SQL Server itself, offer the least privilege that you can to allow people to do their jobs, and make sure that you don't give everyone access to the main admin login, which is the modern day equivalent of people having the SA password.